All right, so really quick. So if you look right here, this is going to describe to us what we're going to use in Desmos. The rest of the video is going to talk to you and remind you how to do it in the handheld. Key thing for the handheld for part 4 of your notes is that with your handheld, sometimes the numbers may be too large and our calculator has limitations, right? The handheld calculator has limitations. So when you're putting the values in, you may not want to use 1950, 1960, 1970. You can choose a starting point. You can do 0, 10, 20, kind of start. And then for the million values, not necessarily write the whole entire million, right? But writing it as like 12.9 million or writing it as, so I can go through and I can write them in friendlier form. Does that make sense? So in the handheld, that's what you would do so that you can make sure you're getting values that our calculator can easily process. Make sense? Okay, so the steps for the handheld are already in your notes. What we're going to do is we're going to practice using Desmos. Got it? Yes? Yeah, we're still using the same table, but we're going to practice using Desmos. The directions, this is the video. The video for the handheld is here, but we're going to practice Desmos. So the steps for Desmos are pretty similar. So in Desmos, we're going to create a table, which we've done before. The new thing here is, though, in our table, we're going to add a second column. To add a second column, you simply just have to click and type Y2. So I'm going to type Y2 and then input the values. We already know that the first rule, our model regression, is Y1 tilde MX1 plus B, right? This time now, because we have a second Y, we have to use Y2 as well, all right? So, yes. All right, so are we ready to go model practice with Desmos? All right, so let's go to Desmos. Again, the full calculator steps are in the video. So I have a blank Desmos screen. I'm going to add a table. And I'm going to add a column. To add a column, again, we type Y2, and that means I'm going to have a second dependent value. Okay? Now, in Desmos, I can put my actual year. So I'm actually going to put in 1950, 1960. So I'm going to put in 1950, 1960, 1970, 1980, 1990, and 2000. Okay? Still with me? All right. Now I'm going to put in my Y1. My Y1 data is going to be New York City, right? So I'm going to put in the populations for New York City, but I'm still going to use them as rounded millions. So 12.9 million. Then I have 14.8 million. Then we have 16.2 million. If you're wondering where these numbers are coming from, it's from our notes on part 4, looking at the table. And then we have 16.1 million. And we have 18.1 million. And then we have 21.2 million. So those are the population values for New York City. Okay. Now I'm going to do the population values for Los Angeles. So in LA, we have 4.4 million, 6.7 million, 7.0 million, 11.5 million, 14.5 million, and we have 16.4. Okay. How do we feel about adding 2 sets of data? Doable? All right, we're going to use this lovely feature that Desmos has added, which is your Zoom Fit feature. Zoom Fit is going to automatically adjust our window so we can see all of our data at the same time. Click Zoom Fit, and bam, there's our data. Look at the match. Okay, now we're going to find our equation of our line for each one of our data sets. Okay, so the first one I'm going to put in is Y1 tilde MX1 plus B, and that's going to be my first equation of a line. So from here, I know that my slope is there, 0.146 4A.571, and my y-intercept is at negative 272.929, correct? You see where it says slope and y-intercept on your blank? Yes. So therefore, my equation of my line would be y equals, and because it's right here and I'm on a computer, I'm just going to copy and paste. X plus make sense? So that's my first one. All I did was copy and paste those values. Yes? All right, now we're going to do the same thing with y2. So instead of typing y1, we're now going to type y2. And we're going to do tilde mx1 plus b. And it's going to now show me my y2. Okay, so the slope of y2 is 0.251143. And the y-intercept is at negative 485.924. So I'm going to type it in. So I have y equals, and again, because I'm on the computer, I'm just going to copy. So this is like the feature on your handheld device where you would store the equation, right? But we can't store, so we're just copying. Plus. Once you've created these equations, you no longer need your regression models. Notice that when I have my two equations, did my lines disappear? No. Okay. How do you feel about finding double regressions? Doable? All right. So now we found our slope and y-intercept and our equation of the line for both. Good. So they didn't ask us at what point is their intersection and what does the intersection mean? Okay. So I'm just going to drag my graph, drag, look for their intersection, and I'm going to click to highlight their intersection. So there's my intersection. What does the intersection mean? Anyone? Okay, it's where the two lines meet. But in terms of this problem, what does the intersection mean? Good job, Joshua, is when the population will be the same. So approximately in the year 2036, if this is the trend that's happening, the population in New York and Los Angeles will be the same. And what is that estimated population? 25.6 million. Does that make sense? All right. So towards the end of 2036, the populations of New York City and LA will both roughly be about 25.6 million if they keep growing at the rate that they're growing and like no major disaster happens. Okay, how do we feel about Desmos and double regression? Doable? Okay, all right, just to make sure it's doable, I want you to start from scratch and you're going to do one yourself. Okay, so here is yours to try. All right, the table shows the winning times for the Olympic 500-meter speed skating. Assuming that these trends continue, when will the women's winning time equal the men's winning time? What will that winning time be? Okay, so go ahead, just go up to the top to the little three lines, start a new graph, and now use Desmos to find in what year and will they have the same time and what would that time be? Got it? As you finish, check with your peers. If you can do this, then you are fully ready to go with the assignment. Got it? All right.